Hey Photography Mafia! In this Darktable tutorial, you're going to learn how to interpret the histogram, waveform, and vectorscope. By knowing how to use these tools, you'll be better able to correct exposure and color grade your images. So let's get started. So we'll first start with the histogram, and I'll use this photo here that I took in the Galapagos Islands. This is a marine iguana. Anyways, going back to the histogram, what exactly is a histogram? The histogram is a graphical representation of the luminance value of a photo as well as the amount of pixels at each luminance value. So it's represented by a horizontal or x-axis and a vertical or y-axis. And it goes from left to right. So the leftmost point is 0% luminance and the rightmost point is 100% luminance. In other words, it goes from the shadows to the highlights, and the middle is the midtones area, and around here is 50% luminance. Some histograms in other photography software represent the luminance range from 0 to 255 or 256 points. That represents the 8-bit RGB color space. And the vertical axis, it represents the amount of pixels at each luminance value. So one thing about the histogram is it doesn't show you the exact amount of pixels that are at each luminance value. It's just a graphical representation. So looking at this histogram, what can we derive? So you can see here is the black point of the shadow. So this is the darkest part of the photo, and this is the brightest part of the photo. And by the way, if you want to change the size of the histogram, you can just like scroll over the base of the horizontal axis and then move it up or down. Sometimes it can be finicky, or what you can also do is you could see this is very finicky right now. Let me just get over here. Okay, that looks better. Another thing you can also do is press Shift plus Option and scroll up or down with your mouse wheel. And I believe that's Shift plus Alt and the scroll wheel on Windows. I'm using a Mac. Anyways, going back to this histogram, this is the darkest point and this is the brightest point. So what that means is it's not evenly exposed, which is okay. This photo still looks good. Sometimes a photo does not have to be evenly exposed, especially if you're doing fine art photography. And as you can see from the histogram, there's a few different channels here. There's the red, green, and blue primary channels, RGB, as well as their complement colors of cyan, magenta, and yellow. And then the composite of the RGB channel is right here, this white histogram. So most of the time when you're looking at a histogram and trying to correct exposure, even when you're trying to do color grading, you might be looking at the white histogram or the composite histogram. And sometimes if you are doing color grading, you might move to the color or the RGB channels. And we can view each of the RGB channels by activating or deactivating their respective histogram by clicking here. So now I only have the blue histogram. I can deactivate the blue and now there's nothing. I can activate the green, but I'll activate them all just to show you what's happening. Now, so if we want to correct exposure in this image, one thing we can do is we can go to the exposure module right here. And then I can map the histogram right here. I can make this part the darkest or the black point, and I can do that by moving the black level correction slider to the right. And then I can do the same thing with the highlights right here. I can map the highlights or the white point, which is right here, to the right, and I can do that with the exposure slider. So it looks a little bit better, or it looks evenly exposed, at least by looking at the histogram. And sometimes while you're moving these sliders around, you do need to balance it out. So I need to move the black correction to the right a little bit, maybe move the exposure to the left or to the right and see how it looks. So now this image looks a lot better. Let's see the before, and this is the after. Keep in mind, Darktable did already automatically apply its own exposure settings. So just remember that, which is right here. Anyways, I'll go back to this one right here. And one other thing about the sliders here is you can see there's an exposure and black level correction slider. Many photography software have a white level. For example, Lightroom has blacks and a whites slider to help you correct exposure. So what I'm going to do is I'm going to reset this image here. And we still have these automatic correction of the exposure right here, which Darktable does. And a few different ways of adjusting the exposure or adjusting the histogram is using the graph. So if I move my mouse over the histogram on the left-hand side, you can see it gets highlighted. So that's the shadows, or the black point, I guess you can say, to adjust the black point. And this is the highlights, or to adjust the white point. So here I can, let me actually, since this looks underexposed, let me actually start with the highlights. So I'll click on this section of the histogram and move it to the right, just like that. And then I'll click on this section of the histogram and move it to the left to map the black point. So that's another way of adjusting the exposure. What I can also do is just hover over these areas and use the scroll wheel on the mouse. So I'm using the scroll wheel now to adjust the shadows or the black level. And now I'm adjusting the exposure slider. So one thing you do need to be careful is while you're moving your mouse over the histogram, you can accidentally adjust some of these sliders. Same thing here. If I move it here, or if I go to this tone equalizer and start moving it around, I can accidentally adjust these sliders with the mouse wheel. So let me just reset this here. Now, another thing I want to show you are the clipping indicators. So the way I can show you the clipping indicator is, the best way is go to this image here to show you this overblown image right now. So let me just get out of this module. Okay, so the clipping indicators represent overblown or underexposed parts of an image. So this icon right here represents what came out of the raw file or the raw image. And if I zoom in here, this is like overblown. I can deactivate the raw file clipping indicator and I'll activate the preview indicator. So this is usually what you want to work with, which is what's going to be rendering and exporting. And this represents an overblown image. The red indicator represents highlight clipping. The blue overlay represents shadow clipping. So let me just go to the exposure module here and I'll overdo the black or the shadow clipping. So you can see right here. And once you start cooking this and overdoing it, like Darktable reacts kind of funny and shows you the clipping indicators a little bit differently. But anyways, let me reset this. And one way I can try to recover the highlights here is by decreasing the exposure, but that starts decreasing the entire image. And that also brings in a little bit of shadow clipping here. So let me just reset this. And what I'm going to do actually is to recover some of this sun here, or this sunset. By the way, I took this photo in Cambodia, the Angkor Wat region. Anyways, I will duplicate this module. I'll create a new instance. And then I will go to this parametric mask. I will turn on the overlay, the mask overlay. And then I'll try to map in the overblown areas just like that. And just like that. Let's see how it looks. So I will turn the mask off. And I will turn off the clipping indicator. And I will try to reduce the exposure. And actually, let me turn on the clipping indicator. And I'm going to reduce the exposure. But you can see now the edges of this image look pretty bad, or the edges of this sunset. So keep in mind, sometimes you can't always recover shadow clipping or highlight clipping. Especially with shadow clipping, if there's a lot of noise in it, you may not want to recover it. But one thing I can do with this image is go back to the mask, which is, let me just turn this on here. And I'll go to the parametric mask, which is right here. And then I can start feathering this in a little bit, or changing the transition, then changing the feather radius, and then blurring that radius. And now let's turn this off and see how it looks. Now this looks a little bit better when I try to recover the highlight clipping. So just keep in mind, you don't always have to recover highlight clipping, especially if there's, or shadow clipping, especially if you're going for a certain fine art look. Just think about black and white photos. Usually there's a lot of dark areas or overblown areas. and the clipping there is okay. And another thing I do want to show you is this soft proofing. So usually with clipping and the clipping indicators here that I'm using, let me just reset this image and turn on the clipping indicator. So this represents usually for adjusting the clipping or recovering highlights and shadow clipping for photos that you're displaying online. But if you want to do printing, you need to work with the soft proofing as well as the gamut checking. So this makes sure your prints represent or print out the colors correctly. So just remember that when you're printing images, you need to do soft proofing in Darktable. Anyways, another thing I can do is, let me see if this is reset. This looks good. Another thing I can do is I can adjust this crop I can adjust this histogram by cropping it. So I can crop right here, and I'll just give you an example, and I can go right here. So now I'm just cropping into the shadows here. So I should see this histogram move if I go to a different module. So you can see it's been pushed all the way to the left. So when you're cropping, the histogram will adjust or compensate for the new crop. Now let me see here. So I want to go to a different image and show you something else. Okay, so let me just turn off the clipping indicators here. This is Bilbo Baggins' house, by the way, in the Shire or in Hobbiton. So one thing I didn't show you yet is the logarithmic histogram, which is right here. So if I click on this, it shows you the logarithmic histogram. And if I click on this, this is the linear or the one-to-one histogram. So the logarithmic histogram, what it does is it accentuates or it exaggerates the lower pixel counts at certain luminance levels. So you can see in the highlight section of this histogram, the blues and the cyan is pretty low in terms of the pixel count. And the reds right here, which is overblown a little bit, it's even lower. So in order to see it a little bit better, you may want to use the logarithmic histogram, which gives you a little bit of a better representation of the histogram. But for me, majority of the time, I usually work with the linear histogram and take a look at the composite. And this is the most common histogram you'll see on digital cameras as well as other photography software. So now we'll take a look at the waveform in Darktable. And just like the histogram, the waveform is also a graphical representation of the image's luminance and the amount of pixels at each value or at each location. The main difference is with the histogram, you don't know where these pixels are. So for example, these mid-tone pixels, there's a lot of them, but we don't know where on the image it is. And there's a few shadow or dark luminance pixels, and we don't know where on the image it is. And I do want to point out that Darktable, for its definition of the histogram and luminance, it uses the word lightness. So it calculates light from 0 to 100% and uses the word lightness instead of luminance. And the difference between luminance and lightness, that's another topic. But a lot of photography software use the word luminance or luma. So anyways, going back to the waveform, it represents the luminance values as well as the amount of luminance at each pixel. So as I was mentioning, we don't know where the pixels are in the histogram, but the waveform, it gives spatial information or spatial data. So it's kind of read vice versa to the histogram, because the histogram, the horizontal axis is the luminance and the vertical axis is the amount of pixels. But on the waveform, the horizontal axis is the representation or the mapping of the image. So the left part of this waveform is the left part of the image. The middle part of this waveform is the middle part of the image. And the right part is the right part of the image. So it's going from left to right. So how do we get the luminosity or the luminance values of this waveform or of this image? It actually gets read through the vertical axis, from bottom to top. So the bottom part right here is 0% luminance. The middle here, there's like a dotted line. That's at 50% luminance. And the top here is 100% luminance. So we can see by the waveform that there's not that many highlights here between, let's say, 80 or 90 to 100%. So that's represented by this area here. There's not that much highlights, so it's not overblown at all. And I can show you that by changing to the logarithmic histogram. So I can close that here and I'll go to the waveform. So what we can do is we can like correct this histogram or this waveform kind of like the same way we did it with the histogram. So this area is the black level correction and this area is the exposure level correction. So I can click, hold, and drag and then just move this up to correct the highlights, or the white level I should say. And then I can bring down the black level again, just like that, just to balance it out. So now the image looks a little bit better. So by adjusting this, we can see when we go to the histogram, this histogram has been moved to the right a little bit. And it looks like it hasn't been fully corrected here. So what I can do is go back to this waveform and I can move it up even more. And remember, sometimes you just can't recover everything, but nothing is overblown here. So I should be able to push this up really high, something like that. Or I can go to local contrast and maybe move the highlights like that and so forth, and just make this image look a little bit better. So let's take a look at the histogram here. So it's more to the right now. And then there's a few, okay, so now actually it's not, it is a little bit overblown because we could not see it with the linear histogram. But now you guys get the point of how the waveform works. And now the waveform is also represented by the RGB channel, just like in the histogram, but you can't really see it well here. So if I click on the RGB parade here, you can see it a little bit better. And the waveform, I usually don't use it in Darktable or any other photography software, but I do use it a lot for video editing and color correcting color and luminance in video editing. So you'll be seeing this type of RGB parade and this luminance waveform, or the Luma waveform, a lot in video editing. But anyways, let me just reset this image here and just go back to the original waveform. So you can see we can't get too much detail because everything's in the middle about reading this histogram. It's almost like the color or the luminance is compressed in this middle area around the midtones, or around this 50% area right here. So to better take a look at this waveform, we'll go back to this image here. So now we can see a little bit of the differences and the changes in this waveform. At first, it looks like this waveform is messed up because of this harsh vertical line, but that's because it's represented by this big black block here, this block right here. And then the sun is in the middle of the image, so it's right here. The red value, or the RGB channels, are up here, or the red channel. And then it's up a little bit here, which I guess is this part of the image. And then you can see this dip right here that goes into the shadows, and that's probably the shape of this structure here. And what I can do is I can go to the crop tool and I can crop this all away just by moving this, cutting this left hand side of the image. So I'm cutting this part away right here. And if I go to the exposure, now you can see the waveform has been changed. And if we look at the histogram, you can see how it's represented. And if we look at the logarithmic histogram, you can see the red channel takes up a lot of the space in this histogram. Now going back to the waveform, of course we can do the same thing with moving the blacks and the exposure and so forth. And another way we can take a look at this waveform is go to this photo here. And this is just to read the histogram, or the waveform I should say. So if we look at this waveform, there's a little bit of red here and a little bit of red here. So that's represented by this orange garment here, and here. And then the door here is overblown or bright. So that's this part of the waveform. And it's on the left-hand side of the image right here. And another thing I didn't mention is the intensity of this waveform. You see how it's actually it's a little bit transparent here. And then here it's super bright, or the brightness is very high. So that means there's a lot of dark pixels right here. So the brightness represents the intensity, or the amount of pixels of the luminance value at that point. So if I go back to this image, This is not a very good image to show you the brightness. Let me see if I can go here. No, that's not good. Yeah, so I'll go back to this image to show the brightness. So we can see, let's see here. Not this one. Let's go to the RGB channel. So this is the red waveform. So this just represents there's a lot more red going from 0 brightness or 100% black to 100% white here, or 100% luminance. But we can see on the bottom part, a lot of the red is dark here. So it's bright right here and it's less bright here. So this represents like around the sun right here, the red channel. And this part represents dark red around, maybe around here. And this is the brightest part right here. In the middle is the super brightest part. So this is the overblown part right here. So the brightness value of this chart, it represents like the amount of pixels at that luminance value. So we can see this curve as well, like right here, this curve of the red. And that's probably moving around this sun right here. And then this is a lot more of the feathering around the sun. And these dark ones are right here. And there's a lot of dark pixels, so that's why it's a little bit more brighter here. The last few things I want to mention about the waveform is you can also change it to a vertical waveform by clicking on this icon here. I'm not too sure in which scenarios you would want to use it. According to Darktable, you may want to use the vertical waveform when you're doing portrait photography and the portrait is quite symmetrical. I can see that case utilizing a vertical waveform. But let me just go back to the regular horizontal waveform. And as you can see, we can have the RGB parade waveform, but if we go to the regular one, we can also just take a look at the individual channels, just like the histogram. And hopefully now you understand how the waveform works. And as I mentioned earlier, I mainly use the waveform for video editing, the Luma waveform and the Chroma waveform. For correcting exposure, I usually just stick with the histogram. Now we'll go over the Vectorscope and see how it represents an image. But before we go deeper into that, let's go back to the histogram. And the histogram, it represents the luminance value and the number of pixels at each luminance value on the image. And in theory, it also gives you the chroma or the saturation of the image because we can see the RGB channel as well. And then going to the waveform gives us additional information because it maps the image from left to right, and it gives us the luminance value as well as the brightness or the amount of pixels at each value represented by the brightness, as you can see. So both of these, waveform and the histogram, gives us luminance information and chroma information. On the other hand, the Vectorscope doesn't give us Luma information or light information. What it gives us is saturation and hue. So right now I'm looking at the RYB Vectorscope, or red, yellow, and blue. Yellow is a primary here, so it's pretty confusing if you're used to seeing a RGB color wheel. And this is the linear RYB Vectorscope, and I can go to the logarithmic one, which looks a little bit better. And then we can change to the different color spaces. So this is the V or the C-Love Vectorscope right here. And this is the AZ-BZ color space. So this is getting into something totally different, into color space and color theory and how we view or work with colors. So I'm just going to go back to this simpler or linear looking one, the RYB one. The one thing you want to be careful is the complements are a little bit different. You can see like yellow has a complement of like cyan or like a greenish one. It's almost like there's a yellow here and an orange one here. But if we go back to another color space, this is red, cyan, green, magenta, blue, and yellow. So this one is a better depiction of an actual RGB color space. But just going back to the RYB one cool thing is it does give us some information or some additional information of color harmonies to help us color grade an image. So these color harmonies are also available on color.adobe.com. That's where I usually get most of my color palettes from when I'm doing color grading or when I'm doing graphic design. I usually wouldn't be using some type of Vectorscope like this, But just to give you an example of how we can use this Vectorscope in Darktable, I'm going to select this complementary color harmony. So right now this image has a lot of yellow, as we can see with the saturation right here. And it has a little bit of blue here as well. And then you can see a little bit of other colors in the middle. So the further out it is, these colors, the more saturated that area or that color is. So the saturation is like the intensity. And then we have the hue here, which is at 60%. This is the color harmony. I can rotate it by moving the scroll wheel on my mouse around, but that's okay. So this is really hard to use the hue on this. That's why I usually use color.adobe.com, but you guys can check that out if you want. But I'm gonna go to the color module here, and I'm gonna use the 4-way to color grade this image slightly. So I'm gonna go to the, where is it, drawn mask, and then I'm gonna go to the gradient mask right here. So the gradient mask is here on the screen. I'm gonna rotate it. That looks good. And then I'm gonna press Shift and move my mouse wheel. Let me make sure I get this correct, to change the transition or the feather of the gradient. So I think that looks good, and I'll just move it here. Now let's take a look at this gradient. So it's impacting right there. So I'll just move it up a little bit more. And actually I'll put a better transition, like about that. So that looks good. I'm gonna hide this gradient. Now I'm in the 4-ways color balance of the RGB module, and I'm going to change the hue to this kind of like a bluish lavender color according to this complementary color harmony. So I'm going to change it to about here. So I should be doing like the math. This is like at 60%, and I always forget if I should be adding or subtracting from this. So that's why I usually just stick with Adobe's color wheel or color management. But anyways, I'm just going to eyeball this. So I'm just going to keep it around, let's say around here, and pay attention to this color wheel or this Vectorscope. As I increase the chroma here, it's going to shift over, and it's shifting over to around here. But I don't want to do it too much, otherwise it's not going to look good. I mean, I can make it look better if I balance out everything, but I'm just trying to give you an example of this Vectorscope and using this complementary color harmony. So I think this looks good, and then I'll just decrease the chroma a little bit. So this is the before and this is the after using the color harmony and the Vectorscope. But personally, I don't see any reason to be using the Vectorscope unless you're really working with like a lot of color and saturation. But other than that, hopefully you guys know how the histogram, waveform, and the Vectorscope works. One good thing about using these is if you don't have your monitor calibrated correctly, or if you change the brightness of your screen, the brightness of your LCD screen, the histogram, the waveform, and the Vectorscope, they can help you color correct your images and correct the exposure a little bit better. But you'll never be able to really tell what color you're looking at unless you're working with the correct color space and you calibrate your monitor. But for me, I don't calibrate my monitor just because I travel a lot and there's always a lot of ambient lighting. Anyways, if you guys enjoyed this Darktable tutorial, you know what to do. And as always, live easy, sleep breezy, and stay lovely.